You're welcome back, guys. We're going to do, and we just to let you know, we just did two problems today. We did Alex, Betty, and Chris, two of the hottest problems in this packet. We did Alex, Betty, and Chris, and we did, I call it Geraldine, Josephine. Of course, the numbers are there and all those things. Where are they coming from? They're all coming from the fractions packet. And it does help to, of course, the fractions are not relevant anymore. Come back, both of you. So the first line is they baked 105. Okay, we're going to use it. Geraldine baked, took 3/5 of the cookies. Let's change the color. That's an important sentence. And this is also an important sentence. Great. 3/5. So I'm going to put 3 under party. And I will try not to mess up, only to under her home. If 3/5 go to the party, 2/5 stay at home. And I would do the same thing here. 2/3 and 1/3. And we're going to make the home red. Not that it matters. Again, each square represents the same number. Each octagon, I don't know how well you can see if they're octagon. They are. Each octagon represents the same number. I do know a couple of things. I do know that all of this is 105. I'm just going to handwrite it. Well, no. Well, I will this time, but then when we finalize it, this is 105. I'll just type it up. That's the question says, the very first line. We also know 66 cookies. This has to be 66. Okay, so I'm going to quickly split it. Remember, our rule is start with the biggest numbers they give you, gradually find out what each square and actually each octagon is worth. So I'm going to get rid of this. 66 and 50, 66 and 105. This has to be 66. This has to be something. This is 66. And this has to be 105 minus 66. I am using my calculator. 39. All right, so okay. Now, again, the way I see it, go to the smallest one, see if you can impose it here, transpose it, put it on top. So, okay, if this is 39, just making sure my number is not off. 105, 166 is 39. So this has to be 39. Oh, let me change the color. This has to be 39. If that's true, this piece has to be 66 minus 39. I think I can do it in my head. 20, I'm going to double check. 27. That sounds about right. So a square plus an octagon is worth 27. When I get that, I'm very close to the end. So that's 27. So this is 27. Clearly. What is the value of each square? 39 minus the same 27 that I just grabbed. 39 minus 27 is 12. Each square is worth 12. That's an important finding. Let's write it here. Each square is worth 12. I'm almost done. Each octagon is worth what? Well, I can totally see that a square and an octagon is 27. Let's see how we can do it. Okay, so sorry about that. This has to be 27 is the value. I know this thing once you, well, we'll see. I know it's a little misplaced, okay? So each octagon, we know an octagon and a square is 27. From 27, if you subtract 12, you're going to get, I believe you're going to get 15. Now we have our finding. We are going to get rid of the writing. Of course, I can do it again. It's not a big deal. Show you how it was done. The question says, how many did Geraldine bake? I'm going to write it here. Baked 12 times 5. That's 60. And Josephine baked 15 times 3, 45. And the good sign, the good news is 45 plus 60 is 105. That's a good sign. And I can check the whole thing. If Geraldine baked 60, this has to be 36. And if let's change the name to Josephine here. If Josephine baked 45, this has to be 30 and 30. I'm kind of checking my work. Plus 36 is 66. So I know for sure my answer is correct. It matches both given conditions. So I'll let you guys decide what you want to do. I'm gonna, if you want me to do another one or anything from the past, that's totally fine. One Geraldine Joseph, another one, Alex, Betty, and Chris, another one. The plan is I'm going to upload some of these practice problems at home. You have 2 examples for each, a little summary again with Geraldine and Josephine. You want to represent that's how I do it. You want to represent the fractions and you want to start with what's given. The big chunks are given, and using the big chunks, try to hone it down to square and an octagon. Do you have to use an octagon? No, use a circle. Who cares? If you don't like symbols, if you don't like shapes, use X and Y. Those of your middle school teachers, even if you use X, it's a good way to introduce your students to variables. Before you jump to letters, kids are totally lost. And we lose a lot of our students to algebra. So it's a good way to teach your kids what variables mean and how to use them in a realistic way, something they can relate to. That's why these problems are in our text and middle school text, not so that you would do it using algebra. They see this actually involves 2 equations, like x plus 3y is equal to some number I'm making up. And they don't do these things in 7th grade. They don't. They see it in high school. So do it like this. I would encourage you to do it like this. But other than that, I'm not going to go over any other problem. I'm going to hang around here for a little longer. But those of you those of you who are here, you can tell me what needs to be done. I'll be happy to address those. So it's from this point forward, it's office hour.
I think I'm good. I think I'm just going to go work on a few of the problems that you have posted. And you're going to post some more of these too?
I will place them actually as probably we speak, but I'm giving you guys a little bit of time. Thank you, Brianna, for coming. Appreciate that.
You're welcome.
All right.
Same with me. I just want to work on like extra problems, so I think I'm good.
Very good, and thank you again for coming, Jersey. Bye.